Hi guys, so last lesson we talked about sodium and water handling by the kidney, and for this lesson what we're going to do is we're going to talk about how the body controls that process. This lesson could easily be retitled Regulating Plasma Osmolarity and Volume, because that's really what control of sodium and water excretion comes down to. So, as you know now, a good part of blood pressure regulation is regulation of blood volume. And in fact, long term, this is the way that your body regulates blood pressure. It isn't through just constantly vasoconstricting all the time. Ideally, what you do is you increase the blood volume to the point where the pressure comes up. Or, if you decrease blood pressure through hemorrhage, ultimately that's not going to be corrected in the body until you retain enough fluid in order to build the blood volume back up. So that's really what the kidneys are in charge of. It's long-term blood pressure regulation. And the way that, and this should make some sense to you now, because the kidneys excrete salt and water. And ultimately, it's the salt and water that determine what the blood volume and the fluid volume in your body is. Because your water is controlled by the osmolarity of the fluid, and the osmolarity of the fluid is defined by really the amount of, a lot of it is defined by the amount of sodium in the fluid. So when you're controlling sodium and you're controlling water, you're really controlling blood volume and controlling the fluid volumes in your body. Okay, and that's what this largely is about. It's about regulation of those volumes through the regulation of sodium and water. So, we've talked an awful lot about blood pressure regulation already in the curriculum, and we've talked in particular an awful lot about short-term regulation of blood pressure. And what we mean by short-term regulation is the classic baroreflex response. Okay. In other words, your baroreceptors at your carotids, there's some in the aortic arch, the major ones are in the carotid. They sense a drop in blood pressure, you get an increase in sympathetic tone, and you get vasoconstriction, your blood pressure comes up, right? We've had that ad nauseum. There are also medium-term blood pressure regulation mechanisms and long-term regulations. Short-term, seconds to minutes, that's your sympathetic system. It takes place pretty much almost immediately. On the order of minutes to hours, we have medium blood pressure control, as we're about to see in a minute, mostly through the release of renin and the formation of angiotensin II. And then we have long-term blood pressure control through control of sodium and water. And that's what most of this lesson is going to be. So this slide demonstrates our short-term and our medium-term blood pressure regulation mechanisms. So here we have this normal short-term response, as you've been learning through the cardiovascular system parts of the curriculum. So we have an increase in blood pressure, or a decrease in blood pressure, that leads to an increase in sympathetic activity, that leads to vasoconstriction, that raises your mean arterial pressure, it raises total peripheral resistance, and it also increases cardiac output through the increased sympathetic activity and a decrease in parasympathetic activity, ups the heart rate, and that increases cardiac output. That also increases your arterial pressure, and that takes place in seconds to minutes, right? It's a neural response, takes place really quickly. On the bottom right-hand part of the slide, we have the medium term blood pressure regulation. And this decrease in arterial pressure causes a decrease in afferent arterial pressure, and ultimately that leads to an increase in renin secretion. And renin causes angiotensinogen to ultimately to be converted to angiotensin II through angiotensin converting enzyme as well. So you increase your plasma angiotensin II, that also causes vasoconstriction. And so that helps increase blood pressure as well. Now this is an endocrine response, so it doesn't happen as fast as our neural response on the left-hand part of the slide. But nevertheless, it happens in minutes to hours. You get this increase in angiotensin II, and that helps with the vasoconstriction, and that helps raise your arterial blood pressure. So here's our medium blood pressure control. Renin release, that promotes angiotensin II formation, that increases circulating angiotensin II, and that causes an increase in vascular resistance. And that ups your blood pressure, okay? Finally, we have long-term control, and this consists of regulating your sodium as well as your water. And so our next two videos are going to be over this. The second one will be over sodium regulation and controlled sodium regulation, primarily through, though not exclusively through aldosterone, and then control of water excretion through the auspices primarily of the antidiuretic hormone. All right? Thank you.